Welcome everyone. This is our final session today on our first day, and we've got Andrew coming to talk about zOS Connect, and in particular some of the updates to zOS Connect that are coming along, and in particular the new OpenAPI 3 protocols. So Andrew, everyone's on mute, but you know that the chats might be coming from us, and we'll shout those out as you go along, and hopefully there'll be time for questions and answers at the end as well. But take it away, please.
Thanks very much, Rob. Good afternoon, good morning. It's always fun with a virtual conference and time zones. As Rob said, my name is Andrew Smithson. I am the architect for zOS Connect, based here in Hursley, where I'm actually speaking to you from today. Really happy to have everyone here to be able to talk to you about the new functionality we've added in zOS Connect to not only support OpenAPI 3 as the latest standard for APIs, but also building it out into hybrid architectures and providing kind of cloud-based deployments and things like that. I'm very happy to take questions, interruptions as we go through. As Rob said, hopefully there's time at the end for a bit of a Q&A, but please feel free to put anything in the chat if you want me to go over anything, clarify anything, or anything like that. So let's just go over a very quick overview of what zOS Connect is. So at its heart, we're what we call a low-code tool for creating RESTful APIs based on the applications and data that you have already on your mainframe. Now, we talk about it being low code because while you may have to write a few bit of XML snippets, the vast majority of what you do doesn't require actual scripting or programming or writing and compiling code in the traditional way. What we provided is a set of tooling, which we will show as we go through, that allows you to build that API up in a very visual and intuitive way. So this has been done through the introduction of a new tool called the zOS Connect Designer. So for anybody that's been with us on this journey with API enablement and zOS Connect, you would have been aware of our API toolkit, which was an Eclipse-based offering, which ran on your desktop and allowed you to build out those R's and SAR files that you needed in order to deploy your API and all the stuff around it. While that was great and it gave us a lot of functionality, we did get a lot of feedback around, installing stuff on my desktop is tricky. I've got to keep up with all these releases. You're coming out monthly and I just can't cope with that. So we've moved the designer to be a container-based offering. So while, yes, it can still run on your desktop, and I will show that in the demo today, you can also run in a cloud environment, such as on Red Hat OpenShift or any other cloud environment that you have where you can run your containers. So that gives you an easy way to build out those APIs based on the OpenAPI specification you're bringing along. So at the very heart of what we're doing within zOS Connect is all around data mapping. And this is the real value and capabilities that I really want you to take away from this talk today. So while the ability to support OpenAPI 3 is great, and it keeps us current with where the industry and all the specifications are going, the ability to actually structure and rearrange the data that you're getting off that mainframe into something that looks and feels like every other REST API that you have within your business or you're bringing in from other parties is the real power that we're looking to leverage with this new functionality, this new tooling in zOS Connect. Now, as I say, if you've used zOS Connect before and our API toolkit, while you could build out that Swagger document, the OpenAPI 2 type document, the data structures, the bodies of your payloads still had a very, what I call COBOL mainframey type feel. If you were using CICS, you could spot DFH in various places. If you were using a channel or a container, those names got populated into the object structures. So while yes, it was JSON, while yes, you were using REST to access the data, it still had that mainframe look and feel. And it didn't always fit the standards. It didn't always fit, what else was happening within the business and the industry. So with the zOS Connect Designer, we've introduced a new set of functionality, new set of capabilities, and a really powerful expression language called JSONata. This is an open source tool that's been developed, and it's there to allow you to work with JSON data and to transform it, to manipulate it, to make it look and feel how you need it to for the data that you want to send and receive from your mainframe applications. And this is really powerful now. When we introduced the API toolkit and things like that, there was a lot of things around, oh, dates need to be in a certain format. Oh, it'd be really great if I could split this string up that comes from my mainframe into 2 fields in my JSON response. It'd be really great if I could concatenate these 2 strings together or change the number formatting or things like that. And all these requirements came into us, and we just looked at them and went, this is a huge shopping list of things that we need to do. And it took us time and effort to get that into the API toolkit. With JSONata, you get that free and more, and we'll show this as we go through the demo. But it really gives you that opportunity to make the data work for you, both in what the API specification requires and what the mainframe application requires as well. So as I say, that's what we talk about when we talk about JSONata and what it does. So there's a couple of links on here. The slides are available via the GSE website. As I say, it's an open source type project. The documentation is really, really good. I mean, used it all the time myself. Just every time it comes up with a question of, can we do this? Go read the docs. There's also a try it out kind of sandbox type thing, which is really useful as well. So if you want to have a set of data or a JSON object that you want to put in there, you can then try out your JSONata expressions, and it will give you real-time answers and evaluation of those queries and selectors and things like that. So you can check out if you need to write something complex, you can try it out and check it's going to work before you start committing it into source code and things like that. So this is just a kind of a list of the sort of things that we can do. All those requirements we had. Can we manipulate the strings? Can we turn something from uppercase into camel case or lowercase? Because we all know that mainframe data likes to shout and be in uppercase at times. Can we do simple mathematics? Can we grab certain values out of arrays or bits out of a string or something like that? Or can we even build our own JSON objects based on other bits of data or extract bits out of that? And that's all possible with JSONata today. So this gives a kind of an initial example of the sort of thing that we want to do. So if we have, say, this JSON object that's come into us, either from the API itself or from the system of records and the database on the mainframe, and we've got 4 fields in there with the last name, the first name, a middle initial, and a height. And we want to create actually a human readable string out of that because that's what our API demands of us. So we can take all of those fields plus some standard text or standard templating type words that go into that, put that all together, and then actually when that gets evaluated as part of the API invocation, then that's the output that we will get. So we get that whole string together. And that's something that happens every time we need to make that application call, that API call. And it's not something that we're then requiring the users of the API to do every time they want to use this kind of thing. So I've talked about it, and now we're going to do the very risky thing of actually trying to build an API live via Zoom as well. So added fun and games with this. But we'll go through and we'll show using the designer, connecting it to a CICS region and getting some of that data out of it. Okay. So this is our designer. It is running as a Docker container. I'm running it on my laptop in this example, but again, equally, I could be running it in a cloud environment. And when I start it up for a new project, the very first thing it asks me to do is to bring in the OpenAPI document that I want to work with. So this is something that has been designed already and implemented and agreed as something between all parties. It may even have gone to kind of an API review board. But we can load it in off the local file system. We'll then go through, we'll do some validation checks about it, check that it is a valid document, something that we can work with, and then give some information about it to check that actually I have selected the right file off my file system. So yeah, Catalog Manager API, version 1.1, That's what I want to build today. So we go and click Create the API, and we get dropped into the new designer interface. So on the left-hand side, we can see all the information about this API. We can see the various paths that have been defined. We can expand into that. We can see the operations that have been defined on those paths. So the things that we need to implement to make this API real. We can also see all the various schemas that have been defined. So we can see we have an error response that might come back. We have our catalog response, and we have links to kind of an item response. And this is a really useful thing that we can now do with zOS Connect. Because we are defining the interface up front in this open API document, we can ensure we've got a consistency between all the responses that we're sending back to the user of this API. So whether they're querying for one item in the catalog or all the items in the catalog, when they're looking at an item, it's always going to have the same structure, the same fields in the same order, with the same layouts. And when we were working with lots of different services, you might be working with different CICS programs, with different input COM areas or different output channels. You couldn't always guarantee that consistency as much as you might want to within the Rs and SARs capabilities we had in the API toolkit. By defining this interface up front, this is the interface that your consumers of your API, your customers, will get and will get every time. So it's a really powerful thing that we're now able to do. So we have lots of exclamation marks that show me that I have something I need to do. So let's go and actually implement getting all the items from the catalog itself. So when we click on the operation, we get a new view. And this shows us the API request as it will come in with all the parameters that have been defined inside that open API specification. So in this one time, we've got a single query parameter for the start item ID. So where we want to start searching in the catalog. We've got a box in the middle, and then we have our responses. And here we can see that we've defined two responses. We've got a 200, everything's worked okay, or we've got a 500, something's gone wrong, and we want to send a response back. And again, this is something that's really powerful and required when you're building out APIs. The HTTP status code that comes back has meaning to the consumer of your API. Hopefully we're all familiar with kind of the idea of a 404 when we're trying to find a web page and it's not available. 404 for not found is actually something that we can use for context in a query for an API. If we're querying for a single item and it doesn't exist, sending a 404 back because that item doesn't exist tells the API consumer, without looking at anything else, the sort of information they've been getting. And the ability to define these elements up front, and as we go through, we'll see how you can start choosing which, when and how you get each of these responses, gives you a lot more flexibility in terms of your APIs. So this box in the middle is for adding the zOS asset. Now, previously in zOS Connect, we had the concept of APIs and services. So your API held your Swagger document, and your services held your information for accessing the CICS program, the IMS transaction, the DB2 query. But as APIs get bigger and more complex, there was suddenly a lot of these to start managing. And you have a lot of things that you have to deploy into your server. You have to make sure they're all being updated at the same time. You have to make sure they're all versioned in the same way. And to try and make it a bit easier, we've done away with having separate things, and we've combined everything into a single API project. So while a zOS asset in theory provides the same functionality as a service, it is different in terms of how you build and manage it, because it's all part of this single API project. So as we click, we get a new wizard. So in this case, we want to add a new zOS asset. We can choose the type of system that we're going to talk to. So at the time of this talk and the version of the designer I'm using, we still just have CICS and DB2. Other subsystems such as IMS, MQ are on our development roadmap. We're looking to get that parity up together as soon as we can. In this example, we're talking about doing CICS. So we will choose a CICS COM area program. My connection is fine. We'll have to go back and do that. So things we need to do. We need to add in right. So before we do anything else, I've got an error that I need to sort out just to prove this demo is live. So if I get to there.
Seem to have lost the sound.
Sorry, that's me. Actually, you haven't lost the sound. I'm just panicking because my demo isn't working as I expected it to.
Okay, no worries.
What I need to do is
Panic
keep
away.
talking through the panic. Yeah, sorry. What we should be having is a connection defined there, and it's not picking up. So I've either put the file in the wrong place. No, it's there. Okay, why is that not being picked up? Apologies. This, as with most things in demos, I checked this out the first time I did it before coming to this call, and it all worked perfectly fine. And now when I try and do it, that'd be why. Because I forgot to change something. Right. So the important thing as well, when we're talking about working in the designer, is we have the ability to connect directly to the systems that we're talking to. So I do this very quickly. So we put in the connection details for the CICS system that we're going to be talking to, and the last bit of prep that I forgot to do. So that should now detect that. There we go. Okay. So the reason we have that as we go through is not only so as we're building out this zOS asset, that we know kind of the name of the connection that we're going to use, because this was a piece of information that was missing when you used to work in the API toolkit. All that information was defined in the server, but it wasn't available to the developer as they were building things out. With the new API projects, we're encouraging the use of kind of server XML snippets. So those connections can be stored as part of the API project. That connection definition with its name is part of your API project. And then at deployment time, you can then specify the host name and port or the credentials, the information that you might need as a deployment option rather than something that's baked in. But we'll come back to that as we go into deployments. So now I've got rid of that warning. We need to add in the name of the program I'm going to call, the language it's programmed in, which is COBOL in this case, the CCS ID I'm going to use, and that CICS connection that I had defined previously and just got working. So with that working, we can then import our data structure. So again, I have that file locally on my file system. So we're now reading in the COBOL copybook that's there for that program that we want to call in CICS. And what we're doing at this point is we're now parsing that copybook, making sure it's valid, something that we can make use of. And we can also then expand it as we're building this and check that actually this is the copybook we want to use. Very easy to get the wrong 8-character name file as you're working on these things, but that certainly looks like the one we want to use. So we can select that and add it as the request structure. And now we've got the response structure that needs to come back. And as it's the same, I can click replicate request structure. With all that done, the final thing we need to do is give it a name. I could give it a description, but in saving time, we'll go forward. And now what we're doing, what the designer is now doing at this point is it is creating and storing all the files and definitions that we need in order to not only call that CICS program, but also to transform any the JSON kind of view of those COM areas into the binary data structures we need to send to CICS and on the responses as well. And with that now created, we can see the zOS asset that we're going to be using here in the middle, and we get a view into the request of what we're going to be able to do and do the mapping into it. So we can see here, this is the JSON view of the COM area that we're going to be using. And there's a few fields that we just need to fill in order to make the call to CICS. So the first thing is that every time we want to query the entire catalog, which is what this operation is doing, we need to put in a request ID of INQ01C. It doesn't matter where I'm starting in the catalog, who's calling it, it's always going to be that value. So we can just define that as a static string, and that will always be copied into that field. The other thing that we want to do is where we're going to be starting from. And this is where we can start mapping in objects from the inputs that are defined inside that OpenAPI specification. So we can get a list of everything that's defined. In this particular case, there's just that single query parameter for the start item ID. So I can click on that. And anything that is specified in that query parameter will then be copied into that field inside our COM area. And that's all I need to do for the request. Everything else will be initialized to low values as required. But as a designer of this API, I only need to put in the values that I care about, or in this case, the program cares about. So that's our request and how we're going to get stuff in to CICS all up and running. Now we need to deal with the response. So in terms of the responses, we talked about this earlier, we have our success case and we have our error case. And we need to determine when we would use one or the other. So again, we have some affordance that there's something I need to do here with this yellow exclamation mark. I can click on the responses and I can start setting conditions, values and if statement type capabilities for the rules on when we should use each of these things. So we can go down. One of the best practices I would recommend if you're doing this, always have your error case as the default. You know, if something goes wrong and you haven't accounted for it, you don't want to send back a success when it didn't succeed. That's one of the worst cases you can get to. Always fail back to an error case. That's my top tip on this one. But if you really need to, you can move these around. So you can change the default to be the 200 compared to the 500. Then we need to define kind of the statements that we want to do. And as we're working in this space, we can use all the same sort of fields that we have for the mappings when we're deciding on what field we want to do. So, you know, if there was an error somewhere inside some parsing, or, you know, somewhere inside kind of working with the inputs for this thing, we have an errored object that we can look at. We also have the response that's come back from the CICS program, including any append codes that might have happened. Now, this is subtly different to what we had with the OpenAPI 2 support. We generally treated any kind of append as an error. Now, that might be true, but we also know that there are CICS programs out there where an append code could mean, actually, I worked, but it was a not found. So actually, you need to send a 404 back. So that's a successful CICS call from a program's point of view. So we need to treat that actually as not a failure from a zOS Connect point of view. So you have the append code you could check, and all the other fields that come back from that CICS program. So in this case, I'm going to use the return code. And as long as it isn't equal to 21, because that's how this program works, we can do a 200. Otherwise, we'll go back and fall into that error code. I'm just going to click around until that disappears. Nope. Must get the development team to sort this one out. Okay. With that set of responses checked, and I'll go back and check what's going on with that in a second, we can now actually go in and start mapping the response as we're going to get it back. And I'm actually going to start with the error because that's quicker and easier. So we just have a simple message that will go back to the user there. So if there's an error, we'll pick the error message out of our error response field. Why are you not saving? There we go. Right. Okay, so now we need to deal with the response that's going through. I told you this was a live demo. It's always risky. So we now have all the fields that are defined inside that open API specification that we saw earlier based on the schemas that are defined within there. So the first thing we have is the total number of items that we have. So we can pick a field out of our response from CICS, CA item count, and we'll copy that value into the response that's going through. As we scroll down, we don't have the ability to do mappings in here right now. And that's because this was defined inside the Open API document, it's defined as an array of items. So we need to map that from something like an occurs inside the copybook. So which occurs do we use? So that's where we start coming into this field, where we can actually pick out the occurs or the occurs depending on that we have within our copybook response, within our COBOL response from the CICS program, and then start using that as the mappings into this array that's going to go back to our customer or our API consumer. So we've got a bit of a clue here. We've got square brackets on this one, so that is an array. So we can pick the cat item. And with that selected, then all the other fields become available. And we can start mapping into these once for every item that we have in that original occurs that comes back from CICS. So we have some summary fields, so we can put some useful messages in there. And we can get some, start looking for things in the array items. Complete with typos. Item on order. So again, we're just taking some of those values and putting them in as part of a string. There are lots of other functions that we have available, and we can start picking out some of the other things. And if we've got some ideas of what they're called, we can actually do some look ahead typing and start pulling them out without having to go search through everything every time. So just go through and finish filling these out. There we go. So that's everything filled out for all our API responses, all the requests that are coming in. And if you have been squinting at my screen as you're going through, you may have noticed this kind of saved icon and this test API whirring away in the background. So every time we make a change inside the zOS Connect designer, we're writing those files back into the project that we've got mounted in. These are all files that live on the file system that can be managed under source control as anything else. But it also gives us this great ability to not only build the API and make sure it works, but to test it. So we have a test UI built in within the designer. And that's why that connection information that we have as part of the development experience is now really useful. But I can actually go away and test my API operation just myself within my own development environment. I've not asked anyone else to deploy it. So we have anything else like that going on. So we were working on the items. Again, we get a view of what's going on, but we can try it out. So we can start with one and run it. This is actually going off, and you actually have a light version of zOS Connect running as part of the designer at this point. So we can go through, and that has worked. So complete with, I've missed a space here. So we know we need to go back and check that. And as we scroll down, a lot of the things aren't working. Okay, right, that's not looking quite as we expected it to. As with all good demos and developers, I can go back and start fixing what I've got wrong here. So we need to put a space in there. Have I picked the right item in stock? Yep. Oops, all worked. So why are you not working properly? Let's try that again. Oh. Excellent. So in theory, this should go back and start getting all the information. I think there's been an update on my CICS server, and that's not quite as we were expecting it to. But we can at least see that we are getting those structures back. The values aren't quite as we expected them to be. So why is that not happening? Okay, apologies. As I said, it is a live demo, but we have at least tried to go off and talk to CICS. Fairly certain. Yep, have talked to CICS. Okay. But we could at least go through, and I can at least show that I fixed that typo. So there is now a space there. So with a bit more time, we could go back through and debug what's going on there. We can make sure all the fields that are coming back have got the right values in them, or are we as we're expecting them to be. And in theory, that was all working well. We could save that, we could check it in, we can go back and work on all the other operations that we have defined inside that API. And then we can go and we can then move on to actually building it and moving it into production environment. I'll take a pause there. Have there been any questions, comments in the chat?
There is a comment from Steve Foley saying try start item 10.
Try start item 10. Thanks, Steve. Nope, still do. I think something's gone horribly wrong in the back end. That's what I'm going to blame. Okay. So let's just wait for that to come up. We built our API. And traditionally, what we then had was that you would take that and you would put it onto a zOS LPAR. There might be an instance of zOS Connect running. You might have two, or just a handful, and they would be running all the APIs within your organization. The title of this slide talks about hybrid deployments and hybrid cloud type deployments. So we've enhanced and extended the places where you can deploy zOS Connect. We still have a native zOS server. That's not gone away. You can still order zOS Connect via a tape. We still have APARs and PTFs that you can apply to it every month to bring that up. But as we look towards a more modern kind of hybrid cloud, hybrid development organization, where we have things like Kubernetes, we have Red Hat OpenShift as part of the organization, it can make sense to run zOS Connect alongside the applications that are also deployed into those cloud environments, where you have a small microservice type architecture where just the API or the APIs that you're interested in for this particular set of capabilities or this overall application are deployed as a single entity, can be managed and upgraded independently of everything else that's running on that system. So that's the other thing that you can do now. We have the ability to run on Kubernetes. That is running on a Linux system. So that can be on S390X, so a Linux 1, Linux on Z type environment, or it can also be on x86. So, or an AMD 64 environment, so Intel based, or one of the hyperscalers such as AWS or Azure. There have been announcements recently from IBM about our partnerships with AWS and Microsoft and how we're looking to do mainframe modernization within those organizations. So if you have those things, or you're working with there, zOS Connect can be deployed and managed into those environments and then connect back into your mainframe. So you can use that as that kind of gateway type thing of working into it. And then we integrate with all the other tools and offerings that you have there. So in terms of actually developing your API and then building it out, there's a very simple, hopefully straightforward type of pipeline that you would want to introduce. We really recommend that all the files that we build out as part of that API project, that you build out as part of the designer, go into some kind of source control management system. within the labs, we use Git and GitHub and that type of things. But, anywhere that you can store files and the change management type scenarios, those files can go into there. We're not pre-recking anything. We're trying to just support whatever pipelines and tooling that you have within your systems. From there, you then need to go and build it, and that will produce what is now a WAR file. So previously we had Rs and SARs. With the combination of the two, we needed a single deployment option, and trying to work more in line with the Liberty server on which we're based, we've taken the kind of the standard WAR file approach. Building the API project is done using Gradle. We'll talk on this in the next couple of slides. But once you have that WAR file, then you get the choice of where you want to deploy it. You can copy it onto the ZFS of a native server running on zOS, plug it into the right directories, plug in the configuration, refresh the server or start it, and everything will work pretty much as it always has done. Alternatively, you can build a Kubernetes image, a container image by copying that in using our server image that's available. And then you can deploy that into your cloud environment. So let's break that down slightly. So let's talk about building your zOS Connect APIs. So we used to have, and we still do for the OpenAPI 2 Swagger-based Rs and SARs, the zOS Connect build toolkit. And that was a thing you had to go off and get. So you downloaded it for free as a licensed user of zOS Connect, and then brought that in. What we're really looking to do, again, with the OpenAPI 3 support and the hybrid cloud and hybrid environments, is to work with tooling that already exists and is familiar to developers across the wider development community. So Gradle is a really great build tool for building all kinds of things. And we've taken this and we're using it for taking all the files for your API project. So all those files that describe how the mappings are going to work, all those files that describe how we talk to the backend system, the CICS program in our previous case. And you have a very straightforward Gradle file that we generate for you. So you get that for free inside your project. And a simple command will take all those files and package it up into the WAR file, ready for deployment or ready for copying to the native server environment. So you just need a version of Gradle, access to the various portals to get the plugins, whether that's directly from your build machine or via a proxy, because you need to be being a bit more careful about these things. But it really comes down to, I get my source code, I check it out, I run my Gradle build, I then have my outputs that I could deploy to an artifact repository, or I can take on and move into my container build that then goes into my container repository. Keep an eye on the time. So we talked about building it, then deploying it. So for a native server, deploying is exactly the same. You're taking those files, you're copying them onto the ZFS file system, either manually or preferably via some automated process, and then refreshing the server or bringing it up again with those updated files. For deploying to a cloud environment such as Red Hat OpenShift, there's a couple of extra steps that we need to go through. So the first of all is that we need to build the API image, and then we need to deploy it. So building the API image is using container build technologies such as Docker, Podman, Builder. Basically anything that can produce an OCI compliant image can be used to build the zOS Connect API image that you need to build for your API. So you take that WAR file, you then take the extra configuration files that you need around connection information, security information, and things like that. They get copied into the image, and then you have your API image built out the back of it. And again, we give you a sample container build file as part of your API project. So it's a case of going in there, updating it to say the version of zOS Connect server image that you want to pull down and use, where to get it from, and running your build command. And that will produce you an API image that you can deploy once, deploy many times, but you're always getting the same version of that API, no matter where or how you deploy it. Speaking of which, we then need to deploy it. Now, one of the great things about Kubernetes OpenShift is a huge amount of flexibility on how you build and deploy things and all the extra resources that you need around it. One of the great drawbacks of Kubernetes is all the extra resources that you have to deploy. And there's a lot of boilerplating type things that come along and things that you just do every time that you deploy something like a zOS Connect API. So in order to make things easier, there's the concept of an operator. And an operator takes kind of all that domain-specific knowledge about, if I deploy an API, I'm also going to want to be able to call it externally, or I want to be able to call it from something else running inside my Kubernetes cluster. Or I want it to pull in information from this configuration setting or from these secrets for security. And there's a whole bunch of stuff there that we can take, and we can give you what's called a custom resource definition for zOS Connect. So instead of having to define 5 or 6 different things in order to get your API live, you can define a zOS Connect thing, and we've taken care of a lot of the underlying linkages and extra resources that are required in order to bring up that API and make it available within your organization. So you then, alongside your API image, you have what's a deployment type piece of YAML, and that would sit there. Again, ideally under source control, because then you can do other DevOps and GitOps type processes alongside that. And that will allow you to deploy and update your API as new stuff comes along. I'll just take a pause again there in case there's any other questions or comments.
No, there isn't. Thank you.
Okay then, some breaking news. This virtual conference has been timed absolutely perfectly, so we can talk about something that's just been released in our last continuous delivery update. So as well as providing the ability to unlock data and applications on your mainframe and expose them as RESTful APIs, RESTful APIs are also something that you want to use as part of your CICS and IMS processing and any kind of batch zOS application type processing. And so zOS Connect has always had, well, for a long time now, the API requester functionality. And that's the ability to call a RESTful API from your CICS program, from your IMS transaction, in a way that's familiar to the CICS programmer or the IMS programmer. So abstracting away all those verbs and URIs and query parameters and giving you a copybook, something that you can just put values into, make a call, and then get the information back again. So in the very latest version of zOS Connect, there is now functionality for doing API requester from CICS for OpenAPI 3 based APIs. But again, we haven't just gone, right, we can support the latest version of the specification. That would be far too easy for us to do. What we want to do is give you value add for doing that as well. There's some great new function that, again, we've added to really kind of make the development experience slightly easier, to improve the quality of the service around performance, memory usage, and things like that. So there's 3 key areas, because we like doing things in 3s. So the first is data areas. So JSON is great because it's unbounded. You can have arrays of unlimited length, and you don't have to specify how big they can be, just that there is an array. And that's great until you get into COBOL, which needs a really big data structure for potentially one element. And we had to, with the OpenAPI 2 Swagger-based stuff, you had to define a maximum size that that array could be. And then your program always allocated enough storage for that array, even if you only got back 2 or 3 items in an array that could take thousands. That's not great for memory usage. It's not very efficient. So we've extended the APIs that the CICS programmer can use in this sense, so that actually they can just start pulling information out. Okay, there is an array, get me the next item, get me the next item. And we only need to allocate enough storage for actually the items that came back. So if you only got 1, it's going to be 1 lot of data. If it's 1,000, then you're still going to need that 1,000, but you're only allocating it when you need it. So hopefully that will improve efficiency, memory usage and things like that as we start putting more stuff through those examples. Secondly, multiple response codes. As we talked about in Provider, the response code and the payload that comes back has a lot of value and meaning when working with REST APIs. And while with the previous API requester function, you could get back that you got something other than a 200 response code, all you got back at that point was then a massive string that was whatever the response was from the API. So you'd lost all that ability to transform it into a COBOL object, into a copybook thing, and work on it in the same way that you would have done the success case. Not anymore. We've worked on that as well. So no matter what the response code you get back from that open API, if it has a JSON payload or a text payload, that will be transformed into something that you can work with in your COBOL program as you would expect it to for any other responses. So you've got much more consistency there. You've got the ability, to check things in a different response code, depending on what you got there, and pick the structure that you need to read into based on that response code. And then finally, this is something that's true for both request and provider, SAF-based security. Our previous versions of support and things like that had a lot of things around, you had to define groups and they were defined in server XML, and then you had an indirection via server XML into your SAF-based authorization groups. And it's not how things are done on the mainframe. And also, it's not really how things are done when you go into a cloud world as well. What you want to do is have something defined within your security domain as this is the group or this is the set that can be done. And so using the standard Liberty authorization functionality now, you have the ability to kind of specify based on SAF groups directly who is able to invoke that API requester, who is able to make a call out of their CICS program into the remote API and make things there. You're not having those indirections and having to update XML files when you just want to make a change inside your SAF groups. So those are the key things. There's plenty of new stuff coming. We are still on our continuous delivery pipeline. There's new stuff coming out every month, new releases, new updates, bug fixes, because we're software that unfortunately is always going to be bugs, but also the new function as we're bringing that along. So please do keep an eye out on our blogs or our social medias and things like that as we go through. And with that, with about 10 minutes left in the session, are there any questions that want to be asked now? Any comments? Anything you'd like to see more of except a working demo? Anything like that?
Okay, so thank you, Andrew. I have unmuted everybody. So if you would like to unmute yourself, then please go on and ask any question you have.
Okay, looks like silence is golden.
I've obviously explained it really, really well there. If there is anything that comes up afterwards, my details are in my speaker profile on the GSE website. Please do get in touch. I'm very happy just to receive questions. We can do other things as well, just to talk through anything that might be going on. Important thing before Rob shouts at me for not doing this, please do your conference feedback. It's really great for us just to understand what's going on here. This has been session 4D. Please do not hold the demo against me when voting on this one, but we'd love to hear that feedback from that.
Thank you, Andrew. I won't shout at you.
Not this time.
No, never. We never do things like that. Yeah, that ends all the sessions for today. If you can fit all the feedback in, it would be really helpful to us, just to make sure that we're pitching this right. zOS Connect has got a lot of affinity with CICS, but I know we've got DB2 users on here, for example. We'd still like to know if we put this in the right place in the agenda. If you think that there are other people, particularly the development community in your areas, that would like to get in touch about this kind of stuff, we're very keen to know that. So we're back tomorrow. That's the last one today, and we've got first thing tomorrow. It's James again with more on securities in session 4F. So thanks very much, Andrew, and thanks for your time, everyone. See you soon.
Thank you very much, everyone.
Cheers.
Thank you.
Bye.